Telco cloud requirements. I have a hard stop at 5:30, right? Is that it? Something? Oh. Half hour? Hey Siri, set a timer for 30 minutes.
Okay, 30 minutes and counting.
I'm good. She'll remind me. Boom. So these are some of the summary use cases: mobile networking, security, voice, CDN caching, access, video content management. By no means is it a full list, and anyone calls me on it, I'll say you have nothing better to do with your time. I just kind of listed more of the important ones that I believe are going to be more predominantly investigated by telcos, and that probably make more sense to their business overall. And there's always going to be the ones where we have a DMS 500 running in software, let's virtualize that as well. That's just a given, right? You're eventually going to want to transition most of that tech over to this cloud platform. So what we know, in terms of a telco cloud and what kind of applications are running today on an existing cloud, there are similarities to web applications. Those are mobility acronyms. If you want to know what they are, come and ask me later. So there's similarity to web apps. There's packet forwarding manipulation, both at the network and security level, things like access list, flow table manipulation. I guess in OpenStack, you'd call that security groups. But the point is, from a telco cloud point of view, there's always packet forwarding manipulation requirements for various reasons. Combination of traditional networking elements. So you always want to take Lego blocks of firewall, net, SBC, load balancers, and all this other good and juicy stuff and connect it all together. And today it's always been a very manual and hardened process. Obviously most people refer to solving that solution via service chaining. I could say you solve, as long as if you had the right open config data models, you could have solved service chaining many years ago if you all just automated it properly. But there's value in doing it in software as well, because there's certain workloads that make sense in x86. CDN proxies and transformation elements, so like transcoding, encryption, and those kind of things. So that's what we know in terms of the applications for common cloud and VNF. So where there's commonality between existing cloud applications and VNF requirements. VNF being what telco clouds are kind of tailoring their cloud environments for. So there's a multi-tenancy need. There's self-service. There's application high availability. General quas. So general meaning there's no shaping requirement. Don't get right down to the bit. Just give me some very basic control of the resource consumption on that host. Orchestration, name your orchestration or etc environment you want to fit it into, Mano, etc. Brownfield app VNF support. So what that means is applications that are already running on an IT environment, say running ESXi hypervisor, naturally those are going to have similar, if not the same, cloud requirements of some VNFs, because they're already running in some of the telcos. So that's the difference too. It's an IT workload running on a telco, but it's not a network function. It's just an IT app running at an organization that happens to be a telco. But nonetheless, it's captured here. So this green blob, what I'm trying to show here, is where the uniqueness starts to come in these VNF requirements and where they start to diverge versus the standard application workloads that you would see in most traditional enterprise clouds versus what telcos are demanding. This came last because low latency, low jitter. You kind of saw it in the previous common cloud orchestration. You see it a lot in gaming, because trust me, 5-10 milliseconds makes a hell of a difference from getting fragged or not, or doing the fragging. But if you look at specifically VNF-only requirements, high packet per second throughput, like tremendous amount of I/O they're asking out of some of these VNFs are asking of the host. Network quas, so right, just from basic port management and QoS, so IP toss markings of certain fields, DSCP fields. You have things like give me policing, give me shaping, give me 6 queues, all those kind of things. That's slowly creeping up. Migration of HA pets to midget cow. That's a Toby 4 term, I'm pretty sure. Search it on Google just to make sure. I'm almost positive it is. But what I mean is, again, most of these VNF vendors aren't going to switch overnight. So a P gateway in a VEPC environment that's using BGP as a mechanism to inject certain GTP tunnel reachability, they're not going to remove BGP. The hardest step is to get the thing in a VM, and they're going to claim success. And even if they want to get rid of BGP, they still have to figure out what's the best way to rewrite their application. Is it just changing BGP to a local API call? Well, you haven't really done much. Your application isn't cloud native. So a lot of them either have to start from scratch, if there's incentive to do so, and or make the transition easier. So we see the requirements coming from across the board from all the different telcos is, I coined a term, so you can hate me later for it, BGP as a service. The reality is, a VNF that wants BGP, now you have to provide a local BGP proxy on that host, so it still thinks it's using BGP as a mechanism to insert network reachability to the world. Even though that's probably not the best way of doing it, ideally, but you want to, again, you want to foster and enable this brownfield migration of VNFs as well. It's all baby steps. VRP is another big one. So geodependency of workloads. So that's essentially another long-winded way of saying distributed clouds. There's distributed clouds in the sense that some applications may have so from an application point of view, you may have different tiers, 1, 2, X, N squared, doesn't matter. The placement of those workloads can actually not only be placed in different points in time, they can actually move at different points in time. So you need an SDN platform that provides this connectivity almost instantaneously and dynamically. That actually surprisingly happens today in the world. It's called the internet. And those technologies are really well baked, and hence why I mentioned in the previous slide why we use a lot of those key building blocks, because these are well-proven mechanisms for dynamic network reachability and reconvergent. KPI measurements of VNF requirements, it's a biggie, right? Telemetry is going to be very important to know what the host is doing or delivering. Actually, it's both. And feeding that back into a system that can consume that data along with other data points and making closed-loop decisions at that level, but then you have hierarchical type of closed-loop mechanisms. Depends on the environment you're working in, but KPI analytics will always be important. It's super important to know what your system is doing from a network level. Obviously, there's going to be other reasons and other parts of OpenStack where you want telemetry, but from a network point of view, it's always important, right? I dropped a phone call 4 weeks ago, or I lost 4 packets. It's like, let me know again, and I'll enable some sniffer, and hopefully I'll figure it out. Where some solutions, if you have analytics built into the forwarding plane in the host, which the Open Contrail does, we pretty much have every record of every packet flow back-ended and stored in an analytics database. And the size of that database in terms of retention is all depends on how much disk space you want to throw at it. Operational transitions and events. That's a biggie. So honestly, if you guys can't run an OpenStack cloud and then upgrade it, you're not allowed to deploy it. That's my point of view. No solution should not be deployed if you can't upgrade it without being able to transition it. We've gotten, at least from a network point of view, which tends to be the biggest piece because networking is what connects everything, period. From a component level, from a framework, OpenStack framework point of view, and then how you get to the rest of the world. We've got it down pretty much to close to a sub-second convergence mechanism. So I think there was a question you asked about how you upgrade these environments. I mean, it's a lot of moving pieces. It's like trying to change the wheels in a moving tire or changing the tires in a moving car. You'll never get, anyone who says NSSU or ISSU is lying to you. There's just honestly no such thing in my view. What you can do is there's two ways to get around this. VNFs by definition today, most of them aren't cloud native. If they were, they would be able to take immediate hits in the infrastructure and it would be fairly seamless to the users. Stateless users. Stateful users, that's a different question and applications can solve that. But until that's done, VNFs are still going to be very much siloed in how they deliver the service. You're always going to have to try to solve the upgrade problem or the state, maintain the state as you upgrade software in the traditional sense. So there's always going to be a hit there. So there's ways of optimizing how you upgrade a system. And that's, to me, that's what I call a carrier-grade environment. And the difference between upgrading a cloud from version A to version B is the difference between seeing no service on my phone to Telco's name here is very important, extremely important. I mean, if you can't do that, then, like I said, you shouldn't be thinking about deploying this stuff. And anyone who says they will and support you for it after you sign a contract, I would suggest you make sure that's the case in the lab before you sign. And then I think the last item that's very important is dynamic tier topology creation, scale-out service chaining. As I'll get into a use case later on. What you'll see is I want to spin up an EPC because capacity X in this part of the state, city, doesn't matter, needs to be spun up. Today, that's typically, depending what's there already and what's not, and I'm sure some people in the room can correct me, it can range from 6 months to literally 24 months, right? If you follow the traditional appliance approach, et cetera, et cetera. But to appreciate why it's so complex, you're literally looking at so many different components and so much different connectivity elements, and then you got the whole support system around it, both how do I build a customer, how do I operate it, et cetera. There's so much complexity there. From a networking point of view, it's also very complex. So the goal should ultimately be is, how do I spin up this EPC within minutes or even within hours with all this dynamic connectivity predefined, but more importantly, it all just comes up, right? Most people will say that's orchestration. Then I usually say if that was the case, then it shouldn't be taking 6 to 24 months today if it was just orchestration. There's more to it, right, to make sure everything works as a cohesive system. Because remember, you're working with an existing system and you're trying to implement new technologies. So what are these unique requirements that telcos have? Packet performance, aggregate flows, peak flows, lots of features. They don't want to give up their features because their networks are using those features. They can't take away from what they've already built. Usually when someone asks me for all 4, I say pick 2, because kind of that's what you'll get. That's a joke, by the way, but it is kind of a whack-a-mole type game in a lot of this case, and why you get divergence in certain applications and what they want versus or application workloads versus VNF workloads, et cetera. But we're making progress. Scale-out networking, scale-out applications, that's very unique, I think, from a connectivity point of view for VNFs. Brownfield enablement, I think I mentioned that. Nothing's ever green with telcos. And communicating and aligning on telco uniqueness. So the key is all these learnings, telcos need to make sure to engage the community and feed that back to make sure the whole community is absorbing that as well. Not only their contributions, but they want the community to feed back their operational experience and their contributions in terms of code and or data models, right? And I think OpenNFV is a perfect example of the community coming together to help solve the operational aspect of this. So. I thought I changed the slide. Okay, I guess I didn't. So if you're a Seinfeld fan, you'll get that. If not, I apologize ahead of time. So worlds collide. Essentially, what you have now is cloud-native apps versus traditional VFs. So to solve for this, you do have a collision of 2 different worlds, right? Enterprise, traditional type workloads versus telcos. So what telco VNFs are asking for? They come up, like I literally get one telco VNF saying, I need 500 or 1,000 packets per second. The next guy comes along and says, I need 50 million packets per second. I'm just like, on the same host? And then I say, why don't you just buy a router or a switch? Then they get upset and walk out. But reality is a router switch is eventually going to end up in the server. And we could just, but that's where I see it going. You can't solve everything. FPGAs is essentially what I'm referring to, right? Custom silicon inside the servers. But as long as it's one big fungible pool, that's the real benefit of that. Aggregate flow performance, again, I see VNFs ranging from give me 1,000 flows to 5 million flows. This is aggregate, sustained flows. Then you got flow creation rate. I want 1,000 flows per second versus 2 million flows per second. I need your system or this host to create these many flows. It's like, again, the reality is these VNF and these operators have been working in a world where the appliances are so optimized and tuned to their applications, they're forcing these requirements onto the new enterprise-type OpenStack environment. There's going to be worlds colliding, right? Then not only is there big personalities not agreeing on how to solve this problem, the typical answer, of course, is make your application cloud native, go away. But some applications can't be, some can. SBC, anything that's in layer 4.7, I think naturally over time can be transitioned to a cloud native type approach. And the vendors who don't want to do it, so I love capitalism, the free market, someone will, and they'll get replaced. And now they have a common cloud infrastructure, it'll actually be much easier to replace them. The problem with appliances before is you were typically locked in. Not just locked in, physically locked in. It's that vendor's piece of hardware, and it actually sometimes would cost more money to go there and rip it out than it did for the equipment because of all the union guys, right? So that's the reality these guys are facing. So, and of course features, I want them all from the last 15, 20 years. No exceptions. So clearly that's an interesting discussion, always is. Proposed solutions, I just mentioned, build cloud native VNFs, and I kind of subtly kind of throw it in there is the reality is if you can't build a cloud native application, the real question you should be asking yourself, should you be virtualizing this workload? Or should I be virtualizing the physical network function instead? What I mean is you hear bare metal as a service, right? I kind of chuckle because that's just a mechanism for allowing existing appliances to exist already as is today, and you connect it to the overlay at the top of rack switch as an example. And there's valid reasons for that, right? Buddy, who wrote some very important stock ticker code for a fintech company 20 years ago, is dead, or they can't find them, and they just can't migrate them off that type of hardware. So there's valid reasons, but that shouldn't be excused. That's an exception, not the norm. Judicious use of SRIOV in traditional cloud workloads. I'm not a big fan of SRIOV, just not. I think it's a good mechanism for bridging the gap for VNFs who think they need to consume an entire host to get 1/10 of the performance of their application. There should be a judicious use of SRIOV. What I mean by that is telcos, in my view, should set up a very stern process saying when a VNF says, I need SRIOV, there has to be a very clear approval process to make sure they make their case. Because if they don't, they're just you're kind of enabling the existing environment or behavior. I'm going to speed up a bit here. Moore's Law, hardware to the rescue. SRIOV workflow integration to the Tor. SmartNICs are essentially FPGAs, kind of like what was referred to or mentioned earlier. And then there's software to the rescue where applicable. You can always do optimizations in DPDK, memory management, flow creation. There's always environmentals you can tune. So I'm going to speed up here just a little bit because I've been told I got about 5 minutes left because I need to leave some room for Q&A. But I guess I did have a 10-minute Q&A. Does that count? I was going back and forth over there. No? I think we need to go out. That's why. There's a party happening out there. I can already hear them. So anyways, scale-out networking. This is how it looks like. Like I said, I'll put on SlideShare so folks can go there and grab it later. Brownfield enablement. I mostly spoke to this. Again, you want to enable existing PNF behaviors in a VNF world. So again, protocol mechanisms. You want to make the transition easy for these VNF owners now. You don't want to change you don't want to flip the world on them completely. But so a cloud environment needs to enable some of these mechanisms. As I mentioned earlier, there's BGP as a service. There's the blueprint as an example. Actually, there's already a third implementation of this, BGP as a service v3, because again, requirements keep evolving based on what the VNF guys want. Live migration of VNFs, geo-distribution, et cetera. And of course, all the good stuff in terms of communicating, aligning telco's uniqueness in terms of requirements to the overall industry. Document your use cases. Ryan did a good job of that, at least today for VES. Was it VES or VE? Yeah. Sorry, I think Verizon Enterprise Services. Documented APIs and data models. Pick your forum. And there's many other mechanisms as well. So I got 2 more slides. So focusing on mobile. It's very hard to put a slide together with mobile technology in one slide. It just is. So at a very high level architecturally, you're going to get always a ton of radio, RAN, telco cloud infrastructure. That's just IP infrastructure end-to-end. Then you're always going to get the internet IP VPN. As you work up the stack, essentially what I'm defining here is what the overall stack looks like from physical right down to the top, meaning the service you're going to be offering. So somewhere in between, you have distributed IaaS. So for my mobility friends, I did mention MEC there. CO pop level distribution, data centers. And then on top of that, obviously, it's an IaaS PaaS layer, which OpenStack and an SDN controller of choice can enable. I put OpenContrail because they pay the bills. Then you got right above that heat orchestration. Heat should be your canonical layer for everything. That's how you should interact with any OpenStack implementation. That's the beauty of heat. End-to-end orchestration, so you got AT&T with their e-com system. They open source that as well. There's more than just obviously provisioning a network and certain compute resources. There's just everything else that comes with that. An IoT platform, I essentially call, this is kind of the holy grail. So in terms of what I think will be the majority of what I call LOB focus, and I'll get that line of business type focus. So here you have the mobile apps, right? VEPC, GILAN, VMME, and a soup of others, P Gateway, et cetera. These are just vertical applications, but again, these are enablers. These aren't the applications. The real focus, what I call, is line of business mobile enablement. So you got connected cars. Essentially, every car nowadays is connected, and everything will be connected. I think relatively soon. Smart cities, MVNOs, Google, Apple, Amazon, they should all want to be MVNOs one day. I'm sure most of the telcos won't want that right away, but I'm sure the government will step in. Asset tracking for fleets or my kids. Connected home, right? Right now, most IoT is a cop-out. It uses IP infrastructure with your local Wi-Fi router. I want pure IoT, right? I want a Nest cam with an IoT built into it using cellular. So regardless of where it is in the world, assuming it's powered, I know that's another issue, I can use it. So I don't like Wi-Fi, even though it's a key mechanism for all of us and how we use it today. I personally think with 5G, it's going to be radio everywhere. Well, Wi-Fi is radio, but you know what I mean. Cellular infrastructure, that's pure ubiquity in terms of connectivity anywhere and everywhere. Aviation, drones, it'll happen 5-10 years. Parallel to power lines, you're going to see a stream of drones just constantly picking stuff up and dropping it off. So they're going to need connectivity anywhere and everywhere, health, you name it. I mean, you can make it up. There's always going to be a disruptor for IoT that's going to want to enable their service, thus satisfying their clientele, but this infrastructure is what's going to enable it all, right? These are key requirements for any type of mobile deployment based on what I've seen for most EPC type deployments as customers come and go, preferably just come and stay. And then I kind of drill down on what an EPC environment looks like. This is the last slide, by the way. So just taking a mid-size, medium-size, and again, your mileage will vary in terms of how many connections you want per area. There's a lot of variables. I just wanted to pick something to quantify it, to give you an idea of where we're at. Just to spin up a simple EPC, medium-size, not a huge amount of capacity, you're talking about 10, 50 virtual machines across dozens of hosts. There's usually up to 50 networking or subnets per instance, and you're talking about tens of interfaces per VM, hundreds of IP endpoints, multi-tier connectivity. You know, there's various different tiers of connectivity between an EPC. You have load balancers, you have firewalls. It's actually the other way around. NAT, you have MCG functions, you have proxy functions for media enrichment. There's, depending again on the service you're trying to offer. The point is, this is why it literally took 6 to 24 months to do anything on an EPC. The point is, how can you do this literally within minutes based on your capacity needs, right? That's the true value of a cloud-enabled telco. These are all the building blocks, policy building, like this soup of names, but the whole point is an EPC may or may not contain some of these or all of them, or it depends on the service you're trying to offer for that region. It can be for a very specific MVNO. Tesla may have a different requirement than BMW, who knows, right? The point is you want to be able to enable this in a very agile way. And these all go into the very specific requirements you're going to need out of the host. What did this all translate to? And I already spoke to this all verbally based on how I defined. All these host requirements, I'll probably zoom in here, there we go. All these host requirements here, at the end of the day, everything you see here on the right-hand side, they all must magically appear in every compute that these things are running. I mean, that's the reality of it, right? So for any type of application as complicated as this, just an example of one, with all these requirements, you're going to need them inherently in the host that you're running them in. No questions asked. If you can find it, you just find your SDN provider of choice that can address all these requirements in your host, and you're good to go. Thanks, y'all. Sorry.
So, one of the key requirements that we see as a significant pain point is the overhead that the control plane takes, especially in small clouds, right?
Mm-hmm.
Like at a CO or at some remote, right? Even imagine a small cell site, right?
Yep, you can have a 3-node control cluster there.
Yeah. So in your example where you had dozens of servers,
Mm-hmm.
your medium, what do you think that the size of the control plane would be? In terms of servers, for example, what's a reasonable expectation?
It all depends on the connect. So the control plane can mean a lot of things, right? But specifically in networking, it depends on your host. If your host is very lightweight but wants to consume and inject tens of thousands of reachability routes, GTP tunnels as an example, that will flow up to the controllers themselves. I don't think, so the question, of course, you're asking, and probably based on experience.
Well, to clarify, what I mean is the OpenStack services that are going to manage those hosts, those VMs in that location including orchestration, the catalog is synchronized with some central catalog, whatever. Everything to make
Keystone,
it
everything.
run
You mean
as a unique cloud, right? The servers that are dedicated to running OpenStack as a service, right, are an overhead. And
Yes.
that overhead is very substantial, especially in small clouds.
That is true. So I think there has to be, and there is some progress being made to essentially try to centralize more of that overhead. But then the problem becomes is what happens when there's loss of connectivity, headless type scenarios that have to be worked out. But you're right, because again, if this doesn't make economical sense for the telcos, then there's no point in doing it. So that's just a long copped-out way of saying, I don't know the answer. We got to work through it, right? And it's actually a clear problem, not only for, I see the common theme coming across cable operators too, who want a very distributed mechanism right down to the set-top box. But of course, they can't have a set-top box running all this overhead, right? So there's going to have to be at some point where you roll stuff back and centralize it a bit. Yeah, I was being nice to Comcast and Cox. Yeah, I don't have anything at home. It's just a TV and a bunch of Apple TVs and Rokus. I consume about 2 terabytes a month.